Children, listen carefully. So today we are going to talk about the factors affecting the amount of work done. What are the factors affecting the amount of work done? In order to explain that particular concept, Sir has introduced a small equation that is nothing but work done is equal to force into distance. That means W is equal to F into D. See, here we are going to discuss the factors affecting the amount of work done. In order to explain that particular concept, I introduced a small equation that is nothing but W is equal to F into D or work done is equal to force into distance. Children, what are the factors which affect the amount of work done? The first factor from this equation only you can understand. The first factor is nothing but the magnitude of force applied. How much force you apply, that is the first factor which affect the amount of work done. How much force you apply, that is one important factor. The second factor in the equation only it shows distance, isn't it? So W is equal to F into D. So we understood that the first factor is nothing but the magnitude of force applied. Second factor is nothing but the distance moved by the body in the direction of force. Yesterday's class are already discussed. Work is nothing but how much force you apply to a body. Because of that force, a body should move. So from here, we can understand that the factors affecting the amount of work done is nothing but W is equal to F into D. According to that equation, the first factor is nothing but the magnitude of force applied. The second factor is nothing but the distance moved by the body in the direction of applied force. Got it? Understood? Now, we understood the two factors. First one is force, second one is nothing but distance. Now, how does force affect the work done? That part we need to discuss. Children, before explaining this first note, I should give one small example. Children, you consider one building. You just consider one building. So that building contains first floor and second floor. So one person is carrying one bucket full of water to the second floor. Another person is carrying, or the same person itself carrying, after some time is carrying a bucket, an empty bucket to the second floor. Just remember, you just consider building, two floors are there. So one person is carrying an empty bucket to the second floor. After some time, he is carrying a bucket full of water to the second floor. So in which condition the person has done more work? With water, isn't it? Bucket with water. That condition only the person has done more work. Why? Because in that case, force is more. To carry that bucket, that particular person should apply more force. To carry an empty bucket, the force applied is nothing but less compared to carry a bucket full of water. So in this particular example, we understood. So when force increased, the work done increases. But the person traveled the same distance, right? To the second floor only. So when the distance is same, under that condition, when the force applied increases, then work done will be more. Got it? Now, listen, W is equal to F into D. That is the general equation which I introduced here. According to that equation, when W increases, that means work done increases, the force also should increase. Or you can say, when the force increases, the work done also should increase. Another condition, when the force decreases, work done also will decrease. You can consider the example of an empty bucket. So in the empty bucket, the force reduced. Am I right? So the work done also reduced. But comparing with the other one with full of water, the bucket full of water, what happened? The force is more in that condition, hence the work done also more. So based on these two examples, we formulated a small equation. Work done is directly proportional to force. Am I right? Because when force increases, the work done is increasing. When force decreasing along with, work done is also decreasing. So from this, we understood the work done is directly proportional to the force. So that statement also I'm given here. Work done is more if the force applied to move the body is more. Understood? Any doubts? Okay, fine. Fine. Listen. Now, the second note is nothing but the dependence of amount of work done on the distance moved by the body in the direction of force. Children, listen carefully. The first note, I introduced one equation. What is that? W is equal to F into D. In this case also, I am introducing the same equation. W is equal to F into D. You just consider same force. Under that condition, that equation will become W is equal to F into D. The force is same. Am I right? Now listen carefully. Children, according to this equation, when the distance increases, the work done also will increase. When the distance decreases, work done also will decrease. So if I explain like this, you won't understand. Let me take one example. Listen carefully. Already I told one example, two-floor building. Am I right? So you consider one person is carrying a bucket full of water to the second floor. After some time, that same person is carrying a bucket full of water to the first floor. So the distance is different. To carry the bucket full of water to the first floor is easy. To carry a bucket full of water to the second floor is difficult. In this two condition, which condition he done more work? When he carry the bucket to the second floor. Why? Because when the distance increased, the work done also increased. Understood? So here from this equation we understood work done is equal to force into distance. When the force is same, that means that particular person is carrying the bucket to first floor or second floor. The force is same, right? Is it same? The force will be same because the same person is carrying and the bucket is full of water itself. But the other condition, first note, there is a small change. First case, he was carrying a bucket full of water. The second case is carrying an empty bucket. But in this condition, we are taking the two condition with full of water, the bucket full of water only. So he is carrying that particular bucket to first floor and second floor. The force applied to the bucket is same only when it carried to first floor or second floor. Why? Why? Because the same person and the same bucket and the amount of water is also same, but the distance traveled is different. So when he travel more distance, when he carry the bucket to the second floor, more work is done. When he carry the bucket to the first floor, less work is done. So when the distance decreases, work also decreases. When the distance increases, the work also increases. Got it? So from this, we understood the equation. Work done is directly proportional to the distance. So work done is more if the distance moved by the body in the direction of force is more. Any doubts? Okay. Now we are going to talk about the definition of work. What do you mean by really work? So yesterday's class, we discussed the general ideas about work. Am I right? So when a particular force applied to a body, because of that particular force, the body will move in the direction of force applied. That is generally we call it as work done. Yeah, it's correct only. Now in this class, we are just updating that. The definition in physics we are going to introduce. So what is the definition of work? Work done is equal to force into distance moved in the direction of force. Work done is equal to the force into the distance moved in the direction of force. For example, children, you can consider one gold box here. In that gold box, I just marked position A and position B. So at position A, the gold box is at rest. Now I am applying a force. Let me consider the force is nothing but around 10 Newton force I am applying to the gold box, which is at position A. Then what happened? The box will move. Am I right? So when a 10 Newton is applied on a gold box, which is at the position A, when I apply force, this particular gold box will move in the direction of force applied. You can see that. So how much distance it traveled from the position A to position B? That is nothing but we consider as the distance moved in the direction of force. And how much force you apply? Both the product, we call it as work done. You just consider once again, gold box at the position A. Now I'm applying a 10 Newton force to the gold box. Then the gold box move in the direction of force and reach the position B. So the distance between position where you applied the force and where it stays now, the distance between position A and position B, that is nothing we call it as D. And how much force you apply, both the product, we call it as work done. So finally, you can assume that work done is equal to force into distance moved in the direction of force. Here, the work done, I'll call it as W. Force, I will denote it as F, capital letter F, and the distance moved, I'll call it as small letter d. Hence, I can write it as W is equal to F into D. Any doubts? Now, what is the definition of this? What is the definition? Without reading the definition, you can explain. Work done is nothing but is equal to the product of force into product of force and the distance moved by the body in the direction of force. Now read the definition. The work done by a force on a body is equal to the product of force applied and the distance moved by the body in the direction of force. Understood? So what do you mean by work done? Work done is nothing but force into perpendicular distance. Sorry, work done is equal to force into distance moved by the body in the direction of force. I hope you guys understood. Fine. Okay. Now, children, I'm going to explain one case. So yesterday, sir discussed that there are certain examples for work done. Along with that, I introduced one more example that is nothing but pushing a wall. A person is pushing a wall. Under that condition, what is happening? A person is pushing a wall. That means that particular person is giving force around 10 Newton or 20 Newton, 30 Newton, some force that particular person is giving, but the distance is equal to 0. So according to our equation, W is equal to F into D, F is equal to 10 Newton or some value, and D is equal to 0. 10 into 0 is nothing but 0. Hence, the work done is 0. Hence, you can understand in that condition, no work is done. So children, listen carefully. Similar example I'm taking here. If a force acts on a body, a particular force, a particular amount of force I'm applying on a body, and the body does not move with that particular force. Pushing a wall is an example. If I apply a particular amount of force to a body and the body is not moving, then W is equal to F into D. That is our equation. F, we have value 10 Newton, 20 Newton, any value you can take, but the distance is 0. Hence, 10 into 0 or force into 0, you guys will get W is equal to 0. Hence, we can say that no work is done. Understood? Any doubts? Now, if F is equal to 0, what happens? Then also work will be 0. If there is no force, there is no displacement. Hence, there is no work. Understood? But this is another condition that is nothing but distance is nothing but if we are considering the distance. So force we apply. When we apply force, also that particular body is not moving to any distance. Because of that reason, work done will be 0. Understood? Fine. So next class, we'll discuss about unit of work. Next class, we'll discuss about unit of work. So children, whatever things we discussed till today, please revise and come. So tomorrow I'll introduce the unit of work. Thank you, children. Have a nice day.